Welcome everyone. Now we'll present the summary of elements of a fixed equipment mechanical integrity or FEMI program based on API 592 guidance document. Please be informed that this summary is intended to simplify the content based on the presenter's interpretation. Agenda 1. Scope, Number A, General Scope, includes, the first scope is, mechanical integrity or MI is essential for the safe operation of process facilities. The second scope is, mechanical integrity or MI applies to, fixed equipment, rotating equipment, mitigation equipment such as LEL or lower explosive limit detectors, deluge systems, gas detectors. Instrumentation and controls. The third scope is, inspection, testing, and preventive maintenance or ITPM are critical for safety and reliability. Number B, purpose of elements of a fixed equipment mechanical integrity or FEMI program. This program focuses on MI programs specifically for fixed equipment. This program excludes rotating equipment and instrumentation or controls, and this program aims to help with, the first is, identifying key elements in developing a fixed equipment MI program using PSM principles or best practices, and the second is, understanding how API documents, codes, and standards integrate into the MI program. Then, number C, limitations of elements of a fixed equipment mechanical integrity or FEMI program. It is limited to intended for use by owner-operators to align with relevant codes and standards. Then, it is limited to not a replacement for a full MI program as required by regulations such as OSHA 1910.119. Then, it is limited to serves as a guidance document based on industry practices. And then, in case of conflict, local regulations take precedence over the document's suggestions. Agenda 2. Fixed equipment in a mechanical integrity or MI program. Number A, when applying mechanical integrity or MI to pressure vessels, there are 4 things to be considered, but not limited to the following. Number 1 is, construction code of the equipment. Number 2 is, process hazards involved. Number 3 is, risk of loss of containment. And number 4 is, potential secondary consequences of equipment failure. Number B, equipment types of fixed equipment covered in an MI program are the following: pressure vessels, storage tanks, piping and pipelines, pressure relief devices or PRDs, fired equipment, critical utility systems, hybrid equipment or fixed other types, and the finally is peripheral fixed equipment. Agenda 3, Written Guidance Overview. Number A, generally, in written guidance of mechanical integrity or MI, shall consider the following. Owner-operators are responsible for developing, documenting, implementing, executing and assessing written procedures for MI throughout the equipment life cycle. Written procedures are essential for an effective MI management system. Influenced by industry regulations and standards relevant to the assets used. Number B, the documentation hierarchy framework includes, Level 1 or sometimes called corporate documentations are pertaining, policies, processes, and systems. Level 2 or sometimes called cross-site documentations are pertaining, programs. Level 3 or sometimes called cross-site documentations are pertaining, practices and guidelines. Then, another group is task-specific activities pertaining detailed procedures. For all those documentation shall be defined by owner-operators which procedures are needed to meet MI program requirements. Number C, use of consistent terminology is important to distinguish between required and optional activities. A structured framework shall enable to the following. The first is, clear planning and execution of MI activities across all organizational levels. The second is, standardized implementation of risk management strategies. The third is, flexibility to address various types and sources of risk. And the fourth is, performance measurement and continuous improvement. Agenda 4, policies, processes, and systems. These elements of a fixed equipment mechanical integrity or FEMI program outline how an organization meets business and regulatory requirements for mechanical integrity or MI. Often referred to as corporate or Level 1 documents in large organizations. Key components include, Number A, define organizational structure, defines roles, responsibilities, and expectations for MI personnel, ensures independence for those responsible for equipment integrity to raise concerns freely. Some regulations require separation between inspection and operations. Number B, contractor and supplier expectations, sets a quality standards for services. Materials and asset quality. Number C, departmental workflows, describes how departments interact and communicate internally and with external agencies. Number D, enterprise systems management, covers systems like CMMS or computerized maintenance management system, IDMS or inspection data management system, and procurement tools. Number D, corporate policies includes policies for system implementation, maintenance, and upgrades. These the corporate policies are risk management, process safety, health, safety, environment, and security or HSE and sustainability. Agenda 5, Fixed Equipment Mechanical Integrity or FEMI programs. Program documents provide more detail under the broader policies and systems, often referred to as cross-site or Level 2 documents in large organizations to support Level 1 documents which covered policies, process and systems. Examples include, number 1 is, Detailed Mechanical Integrity or MI programs. For fixed equipment, rotating equipment, electrical systems, and process controls/interlocks. Number 2 is, Supporting programs. It is to ensure mechanical integrity or MI performance is sustainable. Examples, Management of Change or MOC, Process Safety Information or PSI, Operating Procedures, Project Management. Procurement, Emergency Response, Corrosion Management, Condition Monitoring, and Inspection. Number 3 is, Operational Monitoring Programs, Monitor and Control Process Parameters. Especially important where integrity operating windows or IOWs are defined. These programs should integrate with mechanical integrity or MI systems. See API 584 for integrity operating windows or IOWs guidance. Agenda 6, Fixed Equipment Mechanical Integrity or FEMI procedures. Generally, this procedure sometimes called site-specific or Level 3 documents. It provide detailed practices and guidelines under the mechanical integrity or MI programs. Procedure number A, inspection, testing, and preventive maintenance or ITPM procedures. This ITPM procedures outline strategies for inspecting and maintaining fixed equipment. It aims to detect failure modes and damage mechanisms affecting integrity. Procedure number B, administrative procedures. This is describe how MI-related work is planned, scheduled, and documented. Examples of administrative procedures include, the first is, using CMMS or computerized maintenance management system. IDMS or inspection data management systems. The second is, managing work orders. The third is, maintaining equipment records and reporting equipment failures. Procedure number C, safe work practices. This procedure is to ensure personnel's safety during MI activities. For examples, personnel protection equipment or PPE requirements, lockout tagout or LOTO, hot work permits, confined space entry and line break procedures. Procedure number D, general quality assurance or QA procedures. This QA procedures is to ensure equipment meets design and performance standards. This QA procedures cover the following: O. Supplier and contractor selection or audits. O. Project engineering. And O. Equipment construction and maintenance. Procedure number E, special emphasis program procedures. This procedures focus on high-risk or problematic areas needing extra attention. For examples, buried piping inspection, corrosion under insulation and fireproofing or CUI and CUF, positive material identification or PMI, dead leg inspection and location of specific damage, refer to API 571. Agenda 7, Detailed Work Instructions. Generally, this detailed work instruction is a task-specific procedures that guide step-by-step execution. It is to ensure activities are done safely, consistently, and meet program standards. Detailed Work Instructions number A is Core Maintenance Skill Procedures, for examples, Welding Procedure Specifications or WPS, and Mechanical Joint Assemblies such as ASME PCC. 1. Detailed Work Instructions number B is Inspection, Testing, and Preventive Maintenance or ITPM Task Instructions, for examples, Cleaning Heat Exchanger Bundles, Chemical Cleaning of Piping, NDE, or Inspection. Techniques, Visual inspection of storage tanks. Relief valve testing, pressure or leak testing. And procedures for changes in operating status. Detailed Work Instructions number C is Repair or Replacement Procedures. for examples, welding repairs on piping and vessels, relief valve rebuilds, plugging heat exchanger tubes. And temporary and insulation repairs. Detailed work instructions. Number D is troubleshooting guidelines, for examples, root cause analysis flowcharts, corrosion control documents or CCDs, and manufacturer maintenance guides. Detailed work instructions. Number E is specific quality assurance procedures, for examples, equipment or material purchasing. Warehouse material handling, positive material identification or PMI. And welding procedure qualification records or PQR. Agenda 8, Training and Qualifications Summary. Number A, in general overview, many roles are involved in mechanical integrity programs. Both employees and contractors must be trained and qualified for their specific roles, and these roles are important throughout the equipment's life cycle. Number B is, contractors and employees must be qualified and experienced. Practical experience is just as important as formal qualifications. Training programs help keep skills current and adapt to changes. Some certifications require ongoing learning and documentation, and some companies test contractors' skills themselves, especially for tasks like NDE or non-destructive examination. Number C is local process and safety training. Workers must be trained on the specific units they work in, including understanding processes, damage risks, and hazards. Regular refresher training is recommended. Safety programs should keep workers alert, aware of risks, and ready for emergencies, and training is updated as conditions change. Number D is documentation. Companies must keep records of their employees' qualifications. They must also ensure contractors maintain and provide documentation when needed. Agenda 9, Inspection and Testing. Number A, this is purposed to assess condition throughout lifecycle. Inspections and tests are done to check the condition of fixed equipment throughout its life. A system must be in place to schedule and complete inspections, tests, and preventive maintenance or ITPM to ensure mechanical integrity. Number B, inspections, tests, and preventive maintenance or ITPM tasks. ITPM tasks vary based on equipment type, conditions, and regulations. Common tasks include visual inspections, non-destructive examinations or NDE, tests such as hydrotests, leak tests, and preventive maintenance such as coating or insulation repair. The type of equipment determines which codes or standards apply. Number C, methodology and frequency. Inspection frequency depends on equipment type, damage risks, and regulatory requirements. Three common inspection methods are: time-based, is an inspection and testing scheduled using regular intervals; condition-based, is an inspection and testing scheduled based on equipment condition; and risk-based, is an inspection and testing scheduled based on risk assessment. Different methods may be used for different equipment types. If inspections are delayed, a deferral process must be followed, documenting reason for delay, approval, and new due date. Number C, documentation of inspection and testing. All inspections must be documented. Two key records: the first is inspection report, details of a specific inspection; the second is inspection record, full history of inspections for an asset. The reports usually include equipment ID, inspection dates, type and results of inspection, inspector's name, acceptance criteria, test reports, if any. Most facilities use an IDMS or inspection data management system to store and manage these records. IDMS can also calculate corrosion rates, remaining life, and next inspection dates. Inspection records may also include design and construction info, repair and modification history, fitness for service assessments, and corrosion management data. Agenda 10, Deficiency Management. Number A, types of deficiencies. Type number 1 is equipment deficiencies, physical issues like damage or wear that exceed acceptable limits or don't meet specifications. And type number 2 is program deficiencies, problems in the MI program itself, such as missed inspections, unqualified personnel, or poor documentation. Deficiency management. Number B is equipment deficiency management process. Process number 1 is tracking and managing a system. Like CMMS or IDMS, is used to track deficiencies and ensure repairs are completed. Each deficiency is documented, prioritized, and monitored until resolved. Process number 2 is identifying equipment deficiencies. Found during inspections, engineering studies, incident investigations, or operator rounds, some issues need expert review to confirm if they are actual deficiencies. Deficiencies can be objective or measurable, such as wall thickness below limit. Deficiencies also can be subjective or based on judgment, such as unusual corrosion pattern. Process number 3 is following up on equipment deficiencies. Number A. Following up by prioritizing and resolving. Follow-up by prioritization is based on risk, severity, repair time, and regulations. Follow-up actions may include repairs such as welding and coating, further inspections, and engineering evaluations such as fitness for service. Follow-up by resolving or temporary repairs, like clamps, must be tracked and replaced before expiration. Number B of follow-up on equipment deficiencies is updating plans. If a new or unexpected issue is found, related documents such as inspection plans, corrosion reviews, must be updated. Process number 4 is equipment deficiency recommendation deferrals. If a repair can't be done on time, a formal deferral process is followed, similar to inspection deferrals. Process number 5 is equipment deficiency documentation of closure documentation. All completed actions must be documented clearly. If a repair is no longer needed, a written justification is required. Updates to drawings, inspection plans, and IDMS may be necessary. Program Deficiency Management. Number A. This program covers the systemic issues that weaken the MI program, such as overdue inspections, poor documentation, inadequate training or testing, missing safety information, weak corrosion or maintenance planning, and poor communication or follow-up. Number B. Identifying program deficiencies. Use audits, assessments, and surveys. Effectiveness depends on assessor expertise and employee involvement. Agenda 11, Quality Assurance or QA. Number A. General overview of QA. Quality assurance or QA is about preventing problems by setting clear standards and procedures throughout the equipment's life cycle. Quality control or QC ensures those standards are being followed and helps detect defects. QA and QC work together to make sure equipment is safe and fit for use. Number B. QA for design and fabrication or before installation. Number 1. New equipment must be inspected according to design and construction codes such as ASME PTB. 2. Number 2. Proper documentation and inspection help confirm the equipment is safe to operate. Number 3. For equipment made in a shop, a hold point may be set before shipping to check it meets design specs. Ensure all QA documents are complete. Confirm it's ready for safe transport. Number C. QA for receiving, storage, and retrieval. QA procedures help ensure equipment is correctly received, such as matches order, undamaged, properly stored such as dry conditions for welding materials, isolated to avoid contamination, accurately retrieved for installation, right items, handled properly. Number D. QA for construction and installation, includes, number 1, construction and installation are usually done by contractors or in-house teams. Number 2, QA starts with choosing the right contractor and continues through the entire process. Number 3, procedures and checklists, like weld maps and drawings, guide the work and define quality standards. Number 4, inspections during installation ensure equipment is clean and undamaged, it's safe to operate. Baseline data, like thickness readings, is collected for future monitoring. Number 5, final checks, called punch-outs or walk-downs, confirm equipment matches the design, correct materials were used. Number 6, an integrity test such as hydrodist or pneumatic test is done at the end. Number 7, any issues found must be fixed and documented properly. Number 8, all QA documents are kept as part of the equipment's records and used in the pre-startup safety review or PSSR. Number E, QA for in-service inspections, repairs, alterations, and re-rating. Number 1, QA continues during repairs, inspections, and modifications. Number 2, contractor selection and NDE equipment calibration are important. Number 3, repairs must follow the original design code or a relevant repair code, a repair plan made by a qualified inspector or engineer. Number 4, All work must be authorized and approved as per the code. Number 5, an inspection and test plan is created for each repair or alteration. Number 6, all activities are fully documented to ensure the equipment remains safe and compliant. Number F, QA for temporary installations and repairs. Number 1, temporary repairs, like lap patches or sleeves, follow different standards than permanent ones. Number 2, ASME PCC 2 provides guidance for these. Number 3, companies must have a clear policy to manage temporary fixes and avoid serious risks. Number 4, this policy should be part of the management of change or MOC process. Check if operating conditions or procedures need updates. Ensure staff are informed of changes. Number 5, temporary repairs usually have an expiration date and must be reviewed or replaced before that date. Number G, QA for reuse of decommissioned or purchased equipment. Number 1 is, reusing equipment requires QA procedures to ensure safety and reliability. Number 2 is, keep all design and inspection documents organized. Number 3 is, when moving equipment, use proper labeling and tagging. Number 4 is, decommissioning procedures should include depressurizing and cleaning, preserving equipment, such as draining liquids, purging systems, ongoing inspections and maintenance. Number 5 is, recommissioning involves, fitness for service checks, inspections to confirm suitability for new use. And number 6 is, when buying used equipment, ensure you get design, service, inspection, and repair history. Number H, QA for spare parts. QA for spare parts includes, the first is, identifying critical spares and minimum stock levels. The second is, creating procedures for purchasing, receiving, and approving substitute parts. And the third is, training staff on these procedures. Number A, QA for contractor-supplied equipment. Number 1, QA can be managed by, the owner-operator's QA procedures, or, the contractor's QA program, with oversight. Number 2, the owner-operator must, ensure contractors understand QA requirements, consider auditing the contractor's QA practices. Agenda 12, Roles and Responsibilities Associated with Mechanical Integrity or MI. Number 1, different departments, like operations, maintenance, engineering, and process safety, all have specific responsibilities in the Mechanical Integrity or MI program. Number 2, leaders, site leaders, managers, supervisors, are responsible for assigning resources and making sure the MI program is carried out properly. Number 3, the exact roles may vary depending on the company's size and structure, but every responsibility must be clearly assigned to someone. Number 4, the organization should allow people involved in MI to raise concerns independently if they notice any equipment integrity issues. Number 5, in some regions, inspection and operations roles must be kept separate to ensure unbiased decisions. Agenda 13, Process Safety Information or PSI. Number A, generally, PSI defined as, PSI is part of Process Safety Management or PSM and includes details about process technology and equipment. For fixed equipment or FE, PSI refers to design documents, drawings, and specifications. PSI is grouped into 3 categories. Category 1. Chemical hazards such as safety data sheets. Category 2. Process technology such as process chemistry. Category 3. Equipment details such as design codes, materials. PSI for FE is essential for planning inspections, methods, frequency, and repairs. Number B, PSI Management Program. A program is needed to obtain, organize, and maintain PSI for FE. Key components in PSI Management Program are, Number 1. Ensure PSI is retained for new or replaced assets. Number 2. Use quality control and PSM processes, like MOC or PSSR, to verify documents. Number 3. Organize files by unit or asset, includes, the first is, document handoff process. Define what documents to share, in what format, and when, especially between departments. The second is, update PSI after changes. Any modification, repair, alteration, re-rating, must be reflected in updated PSI. The third is, organize documents. Standardize file structure, by unit and asset, digitize old documents for easy access. PSI management. Number 4 is identify PSI gaps, includes, audit PSI against asset list to find missing info. Action to be take if there is any missing, includes, collect available info such as nameplate photos, contact National Board of Boiler and Pressure Vessel Inspectors or NBBI, if registered, contact manufacturer, using serial number, check legacy files, if all else fails, perform engineering analysis per construction code. Agenda 14, Repair Organizations. Number A, qualified repair organizations or must be certified, different from manufacturers or fabricators such as the following. Manufacturers build new equipment and get certifications, like ASME, API. Repair organizations work on existing equipment and also need certifications. Number B for repair organization is, importance, why they matter. Number 1 is, legal compliance, repairs must meet strict regulations. Number 2 is, safety, ensures equipment operates safely after repair. Number 3 is, quality assurance, certified organizations follow strict quality standards. Number 4 is, insurance, insurers often require certified repairs. Number 5 is, technical conformity, repairs match original design. And number 6 is, documentation, certified repairs include proper records for compliance and liability. Number C for repair organization is, repair stamps, certified organizations can stamp repaired equipment to show compliance. Individuals with code certifications cannot stamp equipment. Common National Board of Boiler and Pressure Vessel Inspectors or NBBI stamps, includes, number 1 is, R stamp, for repairs/alterations on pressure vessels, boilers, heat exchangers, tanks. Number 2 is, VR stamp, for repair/testing of pressure relief valves. Number 3 is, HVR stamp, for heating boiler repairs. For notes, always check the latest standards for updates. Number D for repair organization is, reports. Report number 1 is, repair data reports. Key forms for documenting repairs are, R1 report, details of repair or alteration on pressure vessels or boilers. R2 report, for repairs done in multiple sections or locations. Report number 2 is, repair inspection reports records. These are what to include in the reports and records. The general documentation, includes, pre- and post-repair inspection reports. And NDT results, visual inspection records, photos. Reports and records. The welding-related records, includes, welding procedure specification or WPS, procedure qualification record or PQR, welder performance qualification or WPQ, weld maps, weld testing results. These records are essential for ensuring welding quality and compliance in mechanical integrity programs for fixed equipment. Reports and records. The material certifications, ensure traceability and compliance certificates. Reports and records. The pressure test records, hydrostatic or pneumatic test results. Reports and records. The repair process documentation, procedures, deviations, approvals. Reports and records. The manufacturer's data plate, update if required. Reports and records. The regulatory approvals, keep all required permits and approvals. Agenda 15, Pre-Startup Safety Review or PSSR. Generally, PSSR, also called Operations Readiness Review, is part of the Process Safety Management or PSM program. Number A, for Fixed Equipment Mechanical Integrity or FEMI, PSSR ensures all MI requirements are completed before starting up. Number B, PSSR applies after new installation, repair, or re-rating and after shutdown before restarting. The description of Pre-Startup Safety Review or PSSR are the following. PSSR is a quality assurance review to confirm equipment meets design requirements for intended service, all documentation is updated and stored in the right systems, and procedures and training are updated. Then, PSSR also describe the need of if any issues are listed in a punch list, shall prioritized as, must fix before startup, and can fix after startup, with assigned responsibility and timeline. Number C, checklist, includes, checklist number 1 is, design compliance, site-specific checklist used to confirm readiness, involves authorized personnel from all affected departments. Checklist number 2 is documentation, update asset files with new info and archive old data. Checklist documentation may include updates to operations, maintenance, and emergency procedures. Process inventory lists. CMMS and/or IDMS databases. Relief valve programs. And DCS screens and other site systems. Checklist number 3 is training readiness, and checklist number 4 is punch list prioritization. Agenda 16, Management of Change or MOC, number 1 is, generally, MOC is part of the PSM program. For fixed equipment mechanical integrity or FEMI, all significant changes to processes or equipment must be reviewed, approved, and PSI updated before implementation. Poor MOC can invalidate hazard assessments or compromise safety layers. Number 2 is, initiate for, equipment, process, procedure changes by creating an MOC process. Owner-operator must create a formal process for documenting, tracking, and training on MOCs. And ensuring proper updates to documentation. Then, we need to know when to initiate MOC. We must start MOC for any change in the following: process chemicals changes, technology changes, equipment changes, or facilities changes, for examples, adding or removing or modifying equipment or piping, changing process conditions or composition, updating operating procedures, any change requiring process safety information or PSI update. Number 3 is review and approval. MOC review is done by a multidiscipline team. Number 4 is MI personnel must check for unintended consequences such as increased flow causing vibration and damage. Number 5 is documentation and closure, update equipment files after changes to ensure correct spare parts. This updates is to match replacements to actual equipment and keep MI inspection records accurate. MOC cannot be closed until all records and MI program elements are updated. Agenda 17, Integrity Operating Windows or IOWs, Number A. Generally, integrity operating windows help monitor process conditions that affect the integrity of fixed equipment or FE. They link operations monitoring with the mechanical integrity or MI program. Integrity operating windows purpose to detect when operating conditions accelerate equipment degradation. Number B. Integrity operating windows different from safe operating limits or SOL. Safe operating limits focuses on safety such as overpressure, and integrity operating windows focuses on material degradation and long-term integrity. The correct integrity operating windows make degradation predictable and manageable through inspections. Number C. Establishing limits or integrity operating windows. These are the steps how to establish the limits or integrity operating windows. Number 1. Define process design conditions, pressure, temperature, pH, material, etc. Number 2. Identify damage mechanisms, refer to API 571. Number 3. Set limits for process variables where degradation accelerates, consider all operating scenarios, normal, startup or shutdown, abnormal conditions, group similar equipment for common IOWs, unique cases get individual limits. Limits should be conservative based on risk. Use API 584 for risk ranking and guidance. Number D. Managing integrity operating windows. Number 1. Assign an IOW owner, usually process engineer. Number 2. Integrate IOWs with operational monitoring systems, add extra monitoring if needed. Number 3. Ensure communication between process engineer, corrosion specialist, and inspector. If a limit or integrity operating windows is exceeded, notify corrosion specialist and inspector. Then, assess impact, perform extra inspections if necessary, and then, for the next is to update IOWs when equipment design or operating conditions change, use MOC process. Agenda 18, Key Performance Indicators or KPIs, Number A. Generally, KPIs for fixed equipment mechanical integrity or FEMI helps to monitor performance and track progress, identify improvement areas and make data-driven decisions. And promote accountability and continuous improvement. Number B, examples of FEMI KPIs, includes, number 1 is, overdue inspections and recommendations, number 2 is, loss of containment due to FE failure, by damage mechanism. Failure at indicated locations below minimum thickness during monitoring, number 3 is, number of fitness for service or FFS assessments, level 1, level 2, level 3, number 4 is, number of temporary repairs, number 5 is, number of IOW exceedances, number C. There are common mistakes in implementing the KPIs, includes, aligning KPIs with strategic goals. Unclear goals lead to meaningless KPIs. Every organization has different goals, so KPIs vary, need both leading and lagging indicators, requiring input from multiple stakeholders. Data collection or reporting limitations can make accurate measurement difficult. Sustaining KPIs requires regular review and updates, and there are common challenges in KPIs management, includes defining too many KPIs, reporting too much detail, slow reporting outdated data, no predictive value, using KPIs to assign blame instead of driving improvement. Number D, reporting. KPIs should monitor program health and drive learning. Reporting must be clear, transparent, and audience appropriate, and focused on showing how KPIs support strategic goals. Agenda 19, Program Audits, Number A. Generally, there are two types of audits: compliance-focused, check if codes and regulations are met; internal MI program audit, identify improvement opportunities beyond compliance. These program audits focuses on internal audits for fixed equipment or FE. Program audits. Number B, audit scope. Internal audits should use a documented protocol for consistency. Scope may include basic programs, compliance with codes, inspection programs, written procedures for vessels, piping, PRDs, tanks, boilers, etc., special emphasis programs, damage mechanism specific programs, such as CUI, HTHA, sulfidation, and critical equipment, such as flares. Exchangers, data management and KPIs, data collection, IOW monitoring, KPI reporting, and inspection recommendations. Other topics: repair practices, QA/QC, material verification, contractor audits, PRD testing, NDE providers, program audits. Number C, audit team. Team should include experts in relevant topics and objective reviewers. For multi-site companies, include personnel from other sites or third-party auditors for unbiased perspective. Program audits. Number D, audit activities, field walkthrough, observe conditions, identify focus areas, such as poor insulation, CUI risk, written guidance review, check MI policies, procedures, and plans against regulations. Data review and verification, sample inspection schedules, reports, certifications, repair packages, process safety information or PSI. Expand sample if deficiencies found, personnel interviews, understand program execution and awareness. Program audits. Number E, site organization leadership, evaluate staffing, training, and technical capability of MI team, assess leadership engagement and support for MI program. Program audits. Number F, continual improvement, audit results, identify gaps and recommendations by track corrective actions and verify effectiveness. Here are the key steps to identify, prioritize and track corrective actions in a system of record. Avoid closed with a promise, closing without actual implementation. Verify effectiveness of actions, unresolved issues may persist. Agenda 20, Safe Work Practices, Number A. It is purposed to protect people, equipment, and the environment during mechanical integrity or MI inspection, testing, preventive maintenance or ITPM, and repairs. Number B, Scope. Before starting work, we must identify and apply safe work procedures, permits, and PPE based on the type of work and equipment. Number C. The common safe work practices includes general work permit, hot work, lockout/tagout or LOTO, confined space entry, working on or near live energy, fall protection, rope access, radiation safety, handling hazardous insulation, respiratory protection and breathing air, barricades for work, excavation safety, drone or unmanned aircraft use. Number D. After work, follow facility procedures for closing permits and exiting the site. Agenda 21, Inspection Data Management Systems or IDMS, Number A. Generally, IDMS are digital systems that organize, store, and analyze inspection and integrity data. They support compliance with regulations and data-driven decisions for maintenance, repair, and replacement. Number B, benefits, centralized data storage. Centralized data avoids scattered data sources and inefficiencies, historical analysis, trend identification, and predictive maintenance, easy reporting and analytics, handles large data volumes, requires clear protocols for data entry, labeling, and verification, data integration, combines data from multiple sources, such as NDE tools, monitoring systems, for a complete picture. Enables risk-based inspections and targeted maintenance. Number C, roles and responsibilities. Inspectors' roles and responsibilities is to input real-time data. Engineers or managers' roles and responsibilities is to analyze data, identify trends, make decisions. Compliance managers' roles and responsibilities is to track regulatory adherence. Number D, types of IDMS. Specialized systems for NDT data, integrated systems with enterprise tools, such as CMS, cloud-based. IDMS for remote access. Number E, selecting an IDMS. Key considerations in selecting an IDMS, requirements, define inspection types, data volume, regulations, compatibility, integrate with existing systems, CMS. ERP, scalability, handle future growth and new technologies, user-friendly, easy for all stakeholders to use, data security, encryption, access control, audits, cost analysis, consider total cost of ownership, setup maintenance. Agenda 22, Managing Codes and Standards Updates, Number A. Generally, codes and standards are updated regularly, such as every 2 through 5 years by organizations like API. Number B, updates may change requirements and affect compliance, such as should change to shall. Number C, owner-operators must have a standards management process that includes identifying applicable codes and standards, periodically reviewing updates from publishing organizations, updating internal policies and procedures to stay compliant. Number D. Jurisdictional requirements vary in terms of selection, application, and revisions. Applicable codes depend on jurisdictional requirements. City, state, federal. Authorities may adopt specific codes and enforce them through permits and inspections. Agenda 23, Pressure Equipment Integrity Incident Investigation, Number A. It is purposed to learn from leaks, degradation, or near misses to improve mechanical integrity or MI programs. Number B, improve investigations help refine, design and construction procedures, maintenance and inspection practices, operating practices, such as CCDs per API 970, IOWs, API 584, risk-based inspection, RBA, API 580. API 585 provides guidance on investigating failures and near misses. Number C, investigation process, collect evidence and analyze to find root causes, use recognized investigation methods, involve multiple departments, engineering, maintenance, inspection, operations, supervision, assign corrective actions across relevant teams. Number D, levels of investigation, scope varies by severity, scope depends on severity and potential impact, serious incidents require deeper, more detailed investigations. Number E, sharing lessons learned, communicate findings internally and externally to prevent recurrence and improve industry practices. Thank you.